So I'm just making sure that this video will be available even after the end of the session. Okay, so let us begin. Let us begin with the syllabus. So you people can download syllabus from this site, this A-level computers. I would recommend that you people download this syllabus. You will going to download this thing 2016 syllabus 9608 year 2016. So I probably may have with me this already. So let's start. So this is syllabus for A levels, computer science. If you people are willing to take computer science or engineering as your primary subject or your field in future, so computer science is the primary subject. This will really going to help you out. Right. So in AS we will going to have two papers, P1 and P2. P1 mostly students call it a theory paper because most of the things are theoretical, and A2 is the problem solving. We used to have a pre-release material of P2 as well that we will going to discuss in the next class. Today we will going to focus on P1. All right. So students, do let me know if there is any difficulty at your side. I'm just facing so much silence. So let me know. You can just enabling chat, so you can also chat with me anytime if you feel like things are not going fine. All right. So we're talking about the syllabus. So just like in O levels, in AS as well, it's start with the number representation. So we have how many chapters? We have from 1 to 8. That is 1.1, 1.2, 1.3, 1.4, 5, 6, 7, and 8 lectures. Just give me a second. I'm just coming back in a minute. Just somebody's on the door. Okay, I'm back. So we were discussing about the P1 topics. So okay. So we were discussing about the P1, paper 1, section 1, the theoretical paper for AS 9608. That is from topic 1. This basically this one means that is paper 1, and this is your chapter 1 or the topic 1. So we have total 8 chapters, and then we have the subtopics. So students should get familiar with all the topics and all the numbers. That's a good thing to be carry on with. So number representation will be the first one, then images and sound. Let's see the syllabus in a little bit detail. This is just the overview. Section 3, P3, and then P4. And this is the probably the dividends of the marks in AS and A2. Alright. So here we go. Number representation. Just like we have done in O. If definitely you people have done O with 2210 or with 7010, the old syllabus code. You may have done the binary to decimal, decimal to binary, from binary to hexadecimal, hexadecimal to binary, and then decimal to hex and hexadecimal to binary conversions. So those conversions are important. And then the new thing that in AS is the where is it? Yeah, the ones and twos complement. So in O levels, what we do, we only represent numbers in positive, only the positive numbers. Okay, so what we do when we need to represent, when we tell we need to tell computers the negative number, for example, minus 37. So how to represent that minus sign, that this number, this 37 is not a positive number, but this is a negative number. So we use some other methodology, that is ones complement, twos complement. So this will be covered, and then some introduction with the American Standard Code for Information Interchange, that is ASCII, and the Unicode. It's pretty easy, and this thing I guess what I've seen overall in these this AS and A2 and O-level computer science. This is the information that every person should know in the upcoming world. For this is really important for their if they really want to excel and if they really want to be successful. So this information is really needed. So, all right. Then the binary coded decimal, BCD, or these things should be done. Then we will going to distribute images and the sounds and the video and the compression techniques. Pretty easy. Images, everybody knows about the resolution of the picture and the number of colors, 24-bit, 32-bit. We will going to actually find out how this things works. Sound, how we record the sound inside the computer digitally. We need to sample the sound. You may have heard about MP3 songs comes with like 320 kilobits per second or 480 kilobits per second. So that information will be get here. What the sampling thing means actually, that kilobits per second, the more the better, the more crispier, the more good to listen to those kind of songs. And videos and pictures is almost the same thing, because just like in cartoons, in the old cartoons, what they use, they make multiple pictures and they move quickly, so it becomes a movie. Computer saves every video in the same form. This is the reason that we always talk about frame per seconds in games, FPS, and movies. So one frame means one picture. So if we are going to understand the images, video will come eventually. Like it will be easy for us. Two things that needed to be discussed is the spatial and the temporal redundancy. That's pretty easy. This is the only one small thing that is needed to be covered up. Compression techniques, lossy and lossless, pretty easy. The RLE algorithm, run length encoding, that's easy. So these things will be covered in upcoming classes, hopefully. Network, that we now we are coming to the second chapter of paper 1, that is communication and internet technologies. We are done with the first chapter. Okay, actually we're really not done with the chapter 1, we're just having an overview. All right, so networks, what about the World Wide Web and the protocols that we were going to use, that how this client server thing works. For example, now I'm using Google Hangouts. You people are connecting with me using Google Hangouts. So our computers are attached to that server of Google, and how this whole thing is being actually worked out. So what kind of service is providing us and how it's being done. That is the client server model. This will be discussed. World Wide Web, the devices that are used around the world to connect us, all the computers and all the smartphones and all the laptops and tablets, all they're connected to the internet. So those devices are basically routers, switches, gateways, and servers. This will be discussed, not in much detail, but just enough that you should have an idea. One more very important advice for all my students, which I always tell them, that don't take computer science, especially when you're studying theory, as it's something like English literature, or it's like some other sociology kind of subject which you just need to memorize, and you can say whatever you like. In this, you really need to understand it. If you really understand the topic, then you can really deliver it very good. If you really want to go for aesthetic, memorizing will not going to help you out. You really need to learn that thing, learn those all topics, and learning is basically will going to benefit you all people. So just you have to learn those all things, how these things actually work, the routers and gateways. Alright, then the PSTN, the cellular service, how actually we are going to combine if we are going to use any method by connecting our computers with the routers. The home ADSL router either or it's a switch that is provided by your internet service provider ISP. So are you using copper wire, fiber optic, radio waves, microwave, satellite, etc., etc. So what is bit streaming, um, and what is other things? I guess that maybe it's a bit mixing up. One is bit streaming, then we have circuit switching, and maybe we're gonna see that later on. Okay. So the IP addressing, the Internet Protocol addressing, every computer will going to give a name when it's going on the internet, that is the IP address, and then client server side scripting, that is using Java hypertext markup language. We will going to learn a little bit about JavaScript, a little bit about PHP, but not in much detail. Just enough that when we see the code, we can recognize it that this is the JavaScript and this is PHP, but not much in the detail. So this is how it goes. And we have hardware, that is the third chapter. So all the easy peasy stuff that we have already studied already, the keyboard, the input devices, and the hard disk and SSD, solid state drive, and optical disk, and sensors and actuators, and all those things are here. So this is pretty easy to cover, pretty interesting to cover. This not I guess I don't think so that any extra knowledge, all the previous knowledge will be enough to cover this topic. So usually teachers skip that and throw it on the students to learn them by self, but I'm not going to do that. We will definitely going to discuss it enough that we can score good and we can learn good. Okay, the main memory speed again is same as O levels, nothing extra. All the ROM and RAM and static RAM and dynamic RAM and all that stuff. Logic gates, it's almost the same as O levels. Maybe there could be some one or more things that can be extra. Most of it is just the revision of all. Then the CPU architecture, that is 1.4, and then the fetch execute cycle, the process instruction cycle. This topic needed to be covered with a great interest and attention because when people are going to start the classes with this thing, this needed to be done. This is bit. There is so much silence among my students. Does everybody's here? Yeah, everybody's here. Okay. So these are the assembly language instructions that needed to be learned, and we will going to cover that. Uh,
Hello. Hello, 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 hello. Sir, could you unmute yourself? सर आपको म्यूट कर दिया, आप अनम्यूट कर सकते हैं अपने आप को?
Hello, hello. Oh, I'm back. Who did that? All right. So let's get back. So I guess what we were talking about, we're talking about the data security. So not just the basics, but some extra things that needed to be learned about, that is encryption. So what I've seen in past papers and in CIE, which they really love to ask about, is encryption, the synchronous and asynchronous encryption, and the primary key, the single key or two key encryption. So sorry, not the primary, that is in the database, the private key. So that thing will be covered, and then we have that data integrity, the validation and verification, the parity check and checksums, all these things will be covered here. So ethics, when we talk about ethics, that is 1.7, the seventh chapter. The ethics, not that some particular cultures have different ethics, some different religions have different ethics, but we will going to talk about computer ethics, the freeware, the shareware, and the copyright, and what is the difference in between, and what is good and what's not good. For example, when we talk about ethics, mostly ethics is that the things that actually does not come under the category of punishment, but that's not good to do. Like for example, if you're doing stalking in someone, if somebody forgot the phone, some friend of yours, and you just start, if you know the password and just getting into their messages and stuff like that, that is ethically wrong, but nobody can catch you. So that is ethics. And then we have an ownership that can be challenged, that can be punished if a company have the rights of some software, but unfortunately somebody is distributing the copies of the software without the permission of the company. That comes under the category of punishment. So there are some rules, there are some international rules mentioned, which is punishable and which is not. So we will going to study that. That's pretty easy. Again, ownership of the data software. All right. So there is one big actually table that we used to uh, teach students. So once you're going to get the table, we can answer the questions easily. Database and data modeling, that's again pretty easy. A database management system, just like in O levels, what we have done with the database queries, there are tables given to you, and you have to find out some particular data format. You need to put the queries. And but in this, there is another thing that we will going to be covered is SQL queries. So you should know how to get the data, how to put the data. So we will going to use some those SQL query terms as well. So this will be covered. And then basically when we talk about the file-based approach, that will be covered with your P2, because this is going to make more sense, and we will going to do some of the topics from the P2. So the paper 2 or the problem solving. All right. So these are all that direct data language or data manipulation language, all are the part of that SQL queries that we will going to cover, that create and alter. These are the SQL queries that we will going to do. how to add primary key, etc., etc. This is again interesting when we will going to solve the past papers. Mostly when we cover these topics, specifically these topics, we start with the past papers. We do not start with the theory. So this is how it is being done. And then we have section 2, that is paper 2, that we will discuss later on. So what is the topic that we want to like do right now? Just for the sake of practice, is it that fun? Urban architecture, it's pretty easy. Or we can do this, these logic gates. That's pretty easy one. Everybody loves that. Student loves that because it's like easy to memorize and then just practice it. Or we can do some other topic like number system conversions, binary numbers and hexadecimal number systems. Okay, so when we talk about the gates, shall we do the gates? Can I see any hand raise if few people want to cover some particular topic today? No hand raising. So could you have been muted? Okay. How can I chat? Alright. Chat. Hmm. Which topic shall I pick? Any idea? Just give me a minute. All right. So let's do with the logic gates because that's it's easy. No previous knowledge is needed to be covered with this topic. Nobody is needed with the previous knowledge. Not much explanation is needed to be given on this topic. So only as soon as we will going to learn about all these shapes and the truth tables, and then later on we can just practice this pretty quickly. So let's do it. I will going to use some of the handouts that I've made. Okay, let's do it from the website. Okay. Yes. We can view, we can download. Let's download it. This all notes are available. Basically, notes. These all notes are by from Zafar Ali Khan. He's like very really good friend of mine, and I've definitely have posted those all notes from his permission. So okay, so here we go. So symbols can be mentioned like this, and they can be mentioned as like this. These are called the mil symbols, the military symbols. They name this military because when electronics was actually really evolving at the very beginning, so the U.S. State Department named them as the military symbols. So still they call as MIL symbols. So this is an AND gate, all right, and this is an OR gate, NOT gate symbol. And NOT. You just take the and you take the bubble of the NOT and you combine it and you get what? NAND gate, NOT AND gate basically. And then we have NOT OR gate, the OR with the bubble, NOR gate. And then we have XOR gate, this OR gate. Alright, so then we will going to have the truth table of all those gates, hopefully if everybody remembers that. And if not, let's do it quickly. NOT is simply the inverter. You just give anything to NOT, it will going to invert it. You give basically what you are giving actually, because we are talking about the computers computer only understand binary language, that is 0 and 1. So this is the only numbers, only digits that we will going to play with in logic gates and all whole of the logic circuits. So you give 1, we're talking about the NOT gate. If we give 1 at the input A, it will give us 0 at the output. And if we will going to give 0 in the, at the input, it will going to give us 1. So this is what truth table means. Basically, it's verifying the gate. So what this gate actually behaves like. So when we talk about AND is also known as multiplication gate. Now, why multiplication? We have two inputs, A and B. So you multiply A with B. Let's suppose if what is inside A, it's 0, and then what is inside B, it's 0. For example, we can see here, this is the A input. If we have 0 here, and this is the B input. If we have 0 here, if both are multiplied, we will get the product 0. So A is 0, B is 1. If we multiply 0 with 1, what happens? Again 0. And 1 with 0, 0. Only if both the inputs will be 1, 1 and 1, then we will get the output 1. If both the inputs are high, then we get the output 1 as high. So one more thing to cover in this AS is that you should also familiar with this operators as well. So this means A dot B, because dot basically means multiplication. So A and B are the two inputs. These are multiplied because this is an AND gate, and what is the output here? A dot B, the product of A and B. OR gate, A and B are the inputs. So this is the OR gate, the addition gate. So what will be at the output? A plus B. So what we are going to get? The sum of the inputs, the product of the inputs, the sum of the inputs. Okay. So this is how we move along ahead. Just a minute. I don't know what's taking so long while this blue cursor, this Windows is just moving again and again. What kind of process is actually disturbing it? We're just making it slow. Yeah, the Google Chrome, this is always processor and memory hungry. Alright, we cannot close it because on which we are actually running right now. Alright, so let's move on with the other gates. So NOT and AND. What is the OR? OR is the addition gate, the sum gate. So if any of the input is 1, output will be 1 in OR gate. A and B, 2 are the inputs. 1, 1, 1, 1, 0, 1. Because if any of 1 plus 0 will answer 1. So 0 plus 1 will answer 1. Only if 0 plus 0 will give us 0. So what we say, if any of the input is 1, output will be 1. What happens in the AND gate? If all the inputs are 1, then we get the 1. Even if it's 2 inputs, even if it's 3 inputs, even if it's 4 inputs. If all the inputs are 1, only then 1 will be yielded. And so in OR gate, what happens? If any of the input is 1, output will be 1. NAND gate, simply the opposite of the AND gate. For example, if we are having 1, 1, 1, what happens in the NAND gate? It will become 0. 1, 0 will become 0 in the AND gate. What happens in the NAND gate? It will become 1. You can see that. Okay, it's simply the opposite of the AND gate. Same thing goes with the NOR gate. It's simply the opposite of the OR gate. For example, if if all the inputs are 0, then we have 1. All right. So what happens in the OR gate? If any of the input is 1, output is 1. So this is how it goes. let me check if everything is going. All right, so let's get back. This is teacher from Lahore. All right. Sorry, where was I? We were here. All right. So what is OR gate? OR gate is, it says that if the output will be 1 only if the inputs are not same. So what does this mean? For example, if inputs are same, output will be 0. Inputs are same if, for example, A and B both are zeros. This means inputs are same. They're just like A is 0, B is 0, they are same. So if both are females, we'll get female as the output. And if both are males, we will get 0 as an output. So they should be like dissimilar. So if we have 0 1, output will be 1. If 1 0, then output will be 1. So this is the OR gate. If inputs are similar, output will be 0, else output will be 1. So this is, even again, it goes for the 2 inputs or the 3 inputs and so on. All right, the combination of the gates. Now let's practice it somewhere else on my keyboard. Okay, here we go. That's from the previous class. Okay, we will going to answer that student later on. So let's practice one thing more. Uh, can you people just let me know if I'm drawing this AND gate, and I have another AND gate. That is basically the combination of gates, and we have input A and we have input B. So what we will going to write down here, what will be the output of this gate? It will become A dot B. So it's pretty clear. So this is the third input, that is C. So now what will be the output of this gate? Can you guess? And you can say that that's A dot B. That is the output of the previous gate. This one basically. And it's again getting, this whole thing is getting, and this whole thing is getting and again with which? With the C. Alright? So this will become equation. Now this is the equation, this is the circuit. Now what if you are given with a truth table as well? What you are going to do? Alright, just let's stay on this page and just draw the truth table. A, B, and C. We need another page for the circuit. Okay, let's do it in this way. A, B, and C. And let's take this A dot B, and then the final answer, that will become A dot B dot C. So now we have three inputs. How many possible number of combinations we are going to have? Can anybody answer that? Just remember this formula, 2 raised to the power n. How many inputs we have? We have three inputs. 2 raised to the power 3 becomes what? 6 or 8? Some of my students say 6. They are not good in maths. So if you're good in maths, you're going to answer 8. So if we have 1, 2, 3, three inputs, we are going to have 8 possible number of combinations. Now, what is possible number of combinations? Is just thinking about these A, B, C as three switches. We have three switches, and we want to verify all the combinations. Let's switch off all the combinations. Switch off all the switches. See what happens at the output. All right. So this is what its truth table is about. So actually verifying your circuit, how it actually behaves. Now, the quick method of writing down those combination is that like this 0, 1, 0, 1, 0, 1, 0, 1, and then we have 0, 0, 1, 1, 0, 0, 1, 1. Why I'm doing that? I'm just going to answer that. 0, 4 zeros, and 1, 1, 1, 1. Every combination is different from the other. The first combination is switch off all the buttons, A, B, C. The second combination is, okay, let's check A is switched on, and B is off, and C is off. And let's see what happens ahead. And A is off, B is on, and C is off. Let's see what happens ahead. So this is how it goes. So you can simply answer me what will come here, A dot B. What is happening here? What's happening here? Can you tell me? Basically, that is the AND gate. If all the inputs are 1, only then we will going to get the 1 here in this row. So what is the first combination? 0, 0, and 0. These all are the zeros, so we will get 0. What happens here? 1, 0, and 0. No, still 0. Because if all the inputs are 1, only then we're going to get 1. So this will continue like this. Again, we have, if there is only 1 0 in the combination, the answer will be 0, because you multiply A with B and with C. You multiply 1 with 1, okay, 1. But if you multiply 1 with all these ones with the 0, you'll get 0. 0. Because we have 1 0. 0. Alright, still 0. Only here we will going to get 1, because this is 1, this is 1, this is 1. All the inputs are 1. Output will be 1 in A dot B. My apology, because this is only A and B, so we will going to see only A dot B. We will not going to consider C for this case. Alright, so 0 0 0, 1 0 0, 0 1 0. Just please correct if I'm making mistakes. There is a mistake, 1 and 1, because A dot B. So we will only going to multiply A dot B, not C. So 1 and 1 will become 1. 0 0 0, 0 1 0 0. So we're going to have two ones, and that's pretty easy. So let's move ahead. Now we have done here, we've done this thing. Now for this, what we need to do? What are the inputs? This is the input. We are done here. And the other input is C. So what we will going to look, and what we need to do with these two inputs? We are AND them. We're going to multiply them. Okay, because there is an AND gate. What are the inputs? A dot B is the input and C is the input. So let's start looking at only this A dot B and C. 0 0, they are multiplying, they are getting AND. 0 will be the answer. 0, because we need two ones. 0, 0, 0, and 1. This will be the answer of your this circuit, the combination of gates. So mostly such questions come in CIE with 4 marks, 1 mark if you have two correct answers. So if somebody make a mistake, they will going to like lose 1 mark. So this is how it goes. Right? Discarding it because already my writing is not pretty good. So let's leave it here. Let's get back to the notes. Notes are not very important. Even the book is not pretty important. The reason is that because logic gates only need practice. So practice makes you perfect in problem solving, in logic gates, in SQL queries, in number system conversions, in assembly language. You need more and more practice. So this is a circuit, and this is a truth table, and you can just simply now this S is basically A dot B. Sorry, that is A plus B with whole bar, because this is a NOT OR gate. We represent NOT with a bar. All right. So we continue. So now this is a bit different because the most trickier part of this logic gate is that you will be giving a table, and you will be given with these conditions, and you have to look into these different conditions and follow the table, and then you have to write down an equation. And after writing down an equation, what you need to do, you have to make a circuit out of it, and after making that circuit, you have to dry run this thing as well. So we do have some practice worksheets. May I have uploaded that? Let me check. You can also get into this A-level computer group. I was always available here. You can ask me questions anytime, and you can search by yourself. Yes, logic gates. So you can download, you can preview. These are the practice questions. So all the practice sheets will be available through the page as well. Anybody can get it. So again, a little bit description, a little bit notes before you get into it. Oh, so just like Shahzadah runs, so we already just like copy each of the stuff. A lot of plagiarism actually, but nobody caught us. All right. So these are the practice questions. So they are giving these circuits one, and you have to make a table by yourself. A and B, only two are the inputs, and you have to give X, that is the output. So you just have to tell what will be the X if 1 1. So what will come here? So something like this. And we have the practice questions here as well. So you can just read the questions and you have to answer that. As due to the shortage of time, that we will going to continue this whole topic. Actually, today's class is the purpose of only to bring introduction to you people, to have an idea that how we will going to do this whole thing, and not actually getting into one topic in detail. I know this logic kit is really not done, it's just not even started yet, but we will going to do these things in the next class in detail with lots of practice sheets and more that e-board kind of solutions. So this is about the syllabus so far for the P1. If anything I've missed, the architecture, the fetch execute cycle, the process instruction set, the assembly language. This is the assembly language. We have discussed about the language translators, security, privacy, especially the encryption thing, the firewalls is okay. This is also important, but this is very important. Alright. So this is again important, the parity check, the block parity, and all that things, all that those questions, ethics and ownership, relational, that RDBMS basically, SQL theories. So this is about the paper one. Guys, do let me know. Please do give me feedback and do ask me questions. A lot of questions on page. You can ask questions on Shahzadah's page as well. I'm admin there as well, so I can answer you there. You can ask me questions on my page. You can ask me questions on WhatsApp. And later on, and please do ask me questions during the class as well. I don't know why, but I've seen lots of silence. I feel like I just need some noise. So do let me know. Uh, and let's talk about later. Wish you very best of luck, and I really appreciate that you come and join me. So yeah, Khuda Hafiz, best of luck, and good evening.